In Haber's process for manufacture of ammonia, A. Finely divided iron is used as catalyst. B. Finely divided molybdenum is used as catalyst. C. Finely divided nickel is used as catalyst. And D. No catalyst is required. Now, the Haber's process of for the product manufacture of ammonia is given as N2 plus 3H2 gives ammonia 2NH3. This is ammonia. Now, molybdenum is not used as a catalyst, rather it is used as a promoter. Nickel is also not used as a catalyst. The catalyst used is finely divided powders of Fe, which is iron. Hence the answer is option A. When KCiO3 is heated, it decomposes into KCl plus O2. If some MnO2 is added, the reaction goes much faster because A. MnO2 decomposes to give O2. B. MnO2 provides heat by reacting. C. Better contact is provided by MnO2. Or D. MnO2 acts as a catalyst. Now, the equation is 2 gives 2 KCl plus 3O2. Now, MnO2 does not decompose to give O2. Rather, KCl decomposes to give O2. MnO2 does not also provide heat by reacting because it does not react. There is no reaction in this which involves MnO2. The C option is not correct. Therefore, the option D is correct because MnO2 here in this reaction acts as a catalyst. Therefore, the correct answer is option D. What is the role of a catalyst in a catalyzed reaction? A. Lowers the activation energy. B. Increases the activation energy. C. Affects the free energy change. And D. Affects the enthalpy change. Now, we know that all substance have some average energy which is already there in them. Now, for a reaction to occur, for a reaction to happen, the reactant, the energy of the reactant should be more than the average energy of the substance, more than the average energy. Now, reaction also occurs, but with the help of a catalyst, the reaction occurs faster because catalyst decreases the activation energy, and therefore it helps in the reaction to occur faster. Therefore, here the option is A. It lowers the activation energy. Which of the following reaction is an example for homogeneous catalysis? Now, A. Here are the options A, B, C, and D. Now, when the reactants and the catalyst are in the same phase, then the reaction is known as a homogeneous reaction. Now, in the first example, the reactants are in liquid and gaseous phases. However, the catalyst in the solid phase. Therefore, option A is not a homogeneous catalysis. Now, option B, the reactants and the products are in the gaseous state, but the catalyst in the solid phase. Therefore, option B is also not the answer. In option D also, the reactants and the products are in the gaseous state, and the catalysis is in solid state. Therefore, this is also not the answer. Hence, however, in option C, both the reactants, products, and the catalysts are in the gaseous state. Therefore, this is an example for homogeneous catalysis. Therefore, C is the correct answer. Which is used as catalyst? A. Al2O3, B. CsC2, C. MnSO4, and D. all of these. Now consider this reaction. 2 plus 2KMnO4 plus 3H2SO4 gives 2MnSO4 plus K2SO4 plus 8H2O plus 10 CO2. Now in this reaction, addition of a few crystals of MnSO4 greatly accelerates the reduction of oxalic acid of purple KMnO4 to ready colorless manganese. KMnO4 to manganese. When no manganese ion is added, the reaction initially proceeds slowly, but the rate gradually increases. Gradually increases because the product manganese autocatalyzes the reaction. Therefore, MnSO4 autocatalyzes this reaction. Therefore, the correct answer is option C. An example for autocatalysis is oxidation of NO to NO2, B. Oxidation of SO2 to SO3, C. Decomposition of KSlO3 to KSl and O2, and D. Oxidation of oxalic acid by acidified KMnO4. Now, if we consider the following reaction, here the pink color of the KMnO4 slowly disappears on treating it with oxalic acid. But the rate of disappearance of color fastens after some time due to the formation of Mn2 plus ions, which acts as an autocatalyst for the reaction. Hence, the correct answer is option D, oxidation of oxalic acid by acidified KMnO4. Formation of ammonia from H2 and N2 by Haber's process using Fe is an example of A. Heterogeneous catalysis, B. Homogeneous catalysis, C. Enzyme catalysis, D. Non-catalytic catalysis process. Now, the catalytic process in which the reactants and the catalyst are in different phases are known as heterogeneous catalysis. Now, the formation of ammonia from H2 and N2 in Haber's process is given as N2, which is in gaseous state, plus 3H2, which is also in gaseous state, gives 2NH3, which is also in gaseous state. However, the catalyst used is finely powdered Fe, which is in solid state. Therefore, here the reactants, products and the catalyst are in different states. Therefore, this is a heterogeneous reaction. Therefore, the answer is option A. Which of the following is used as a catalyst in the manufacture of toluene from benzene with CH3Cl? A. Ni, B. Anhydrous AlCl3, C. PD, and B. PT. Now, the reaction which converts benzene into toluene using CH3Cl is C6H6, which is benzene, plus CH3Cl gives C6H5CH3, which is toluene, plus HCl. Now, in order to catalyze this reaction, we use anhydrous AlCl3, which reduces the activation energy of benzene and it converts into toluene. Therefore, the correct answer is option B. Hydrolysis of ethyl acetate is catalyzed by aqueous A. Na2SO4, B. K2SO4, C. H2SO4, and D. BaSO4. Now, the hydrolysis of ethyl acetate is given by the following reaction: CH3COO C2H5 plus HOH gives the reaction as CH3COOH plus ethyl alcohol C2H5OH. Now, here, in order to catalyze this reaction, we make use of concentrated H2SO4. Therefore, the correct answer is option C. In the Ostwald's process for the manufacture of HNO3, the catalyst used is A. MO, B. Fe, C. Ni, and D. PT. Now, the Ostwald process for the manufacture of HNO3 is given as 4NH3 plus 5O2 gives 4NO, which on further oxidation gives 4NO2, which on further gives 4HNO3, which is the manufacture of ammonia. Now, here the catalyst used in the first step is PT gauge. which is used at a degree at 11,000 Kelvin, 1100 Kelvin. Therefore, the catalyst used is PT, which is answer D. Which acts as autocatalyst during the titration of KMnO4 and oxalic acid in the presence of H2SO4? A. H2SO4, B. KMnSO4, C. Oxalic acid, and D. MnSO4. Now, the reaction of the titration of KMnO4 and oxalic acid in the presence of H2SO4 is given as oxalic acid plus KMnO4 plus H2SO4, 3H2SO4 gives 2 MnSO4 plus K2SO4 plus 10 CO2 plus 8 H2O. Here MnSO4 acts as an autocatalyst during the titration of KMnO4 and oxalic acid in the presence of H2SO4. Hence the correct answer is option D. Amongst the following chemical reaction, the one representing homogeneous catalysis is A. N2 plus 3H2, which gives ammonia, which is Haber's process. B. 2SO2 plus O2 gives 2SO3 plus 2NO. C. CO plus 3H2 gives CH4 plus H2O. And D. 2SO2 plus O2 gives 2SO3. Now, what is homogeneous catalysis? When the reactants products and the catalyst are in the same phase, then the reaction is called as a homogeneous catalysis. Now, in the reaction 2SO2 plus O2, which gives 2SO3 plus 2NO, here the reactants and products are in the same state, which is the gaseous state. Here the NO, which is the catalyst, is also in the gaseous state. Hence, this is a homogeneous catalysis. None of the other three are homogeneous catalysis. Therefore, the correct answer is option B. As2S3 solution has a negative charge capacity to precipitate it is highest in A. AlCl3, B. Na3PO4, C. CaCl2, and D. K2SO4. Now, negatively charged As2S3 solution is coagulated most effectively by AlCl3. Correct answer is actually A. This is because oppositely charged Al positive ions have maximum charge. They have the max charge. So actually the relation goes As3 plus is more than Ca2 plus is more than Na plus. Therefore, the correct answer is A. On addition of 1 ml solution of 10% NaCl to 10 ml gold solution in the presence of 0.25 gram of starch, the coagulation is just prevented. Now, starch has the following gold number: A. 0.025, B. 0.25, C. 0.5, and D. 250. Now, by definition, the gold number of starch is the amount of starch in mg added to 10 ml of standard gold solution, which prevents the coagulation of gold on adding 1 ml of 10% NaCl solution. So the amount of starch is 0.25 grams, which is equal to 250 mg. Therefore, hence the gold number is 250. Therefore, the correct answer is option D. Now, gold numbers of protective colloids A, B, C, and D are 0.50, 0.01, 0.10, and 0.005 respectively. The correct order of their protective power are, here are the options. Now, by definition, gold number is inversely proportional to the protective power. Therefore, we have to find the protective power. Therefore, protective power PP will also be inversely proportional to the gold number. Hence, if the gold number decreases, the protective power will increase. Here, now, and also if the gold number is more, the protective power will be less. So here, firstly, the A has a gold number of 0.50. Therefore, it has the least protective power. Now, in the only options where A is small is option B. Therefore, the correct answer is option B. We can check after A, C has the lowest protective power. After C, B has the lowest, and D has the greatest protective power because it has the least value of the gold number. Therefore, the correct answer is option B. The number of moles of lead nitrate needed to coagulate 2 moles of colloidal AgIl minus is A2, B1, C half, D2 by 3, and E 5 by 2. Now, the reaction to coagulate is given as 2 AgL I negative plus Pb2 plus gives Pbi2 plus 2 AgL. Now here, thus 2 moles of Agi minus has 2 mole negative charges. It is equivalent to the total charge on Pb2 plus. Therefore, 2 negative is equal to the 2 positive mole of the lead nitrate. Therefore, the answer is actually 2 by 2, which is 1. Therefore, 1 mole is needed. 1 mole of lead nitrate is needed. Therefore, the correct answer is option B. The volume of a colloidal particle Vc as compared to the volume of a solid particle in a true solution Vs could be A. Vc upon Vs is proportional to 1. B. Vc upon Vs is proportional to 10 is to 23. C. Vc upon Vs is proportional to 10 is to minus 3, and D. Vc upon Vs is proportional to 10 is to 3. Now, if we just compare the rough values, we can get Vc upon Vs is proportional to 10 raised to minus 5 upon 10 raised to minus 7. These are just the comparable values which are now taken here. So, on dividing, we get the values proportional to 10 raised to 3. Therefore, Vc upon Vs will be proportional to 10 raised to 3. Therefore, the correct answer is option D. Which has the least gold numbers? A. Gelatin, B. Starch, C. Albumin, and D. Blood. Now, I'll just write the values which of these numbers, the gold number ranges which all these substances have. So, substances and their gold numbers. Now, gelatin varies from 0.005 to 0.01. Now, starch has gold number in between 25 to 50. Now, albumin has gold number from 0.10 to 0.2, and blood has a gold number of 0.03. Therefore, among all, gelatin has the least gold numbers. Therefore, the correct answer is option A. The charge of FeOH3 solution is due to adsorption of hydroxyl ion, adsorption of hydrogen ion, C. adsorption of ferric acid, and D. adsorption of ferric ion. Now, FeCl3 is added to excesses of hot water, a positively charged solution of ferric hydroxide. So is formed due to the adsorption of Fe3 plus ions. So basically, FeCl3 is added to excessive hot water. A positively charged solution of ferric hydroxide is formed due to the adsorption of Fe3 plus ions. Therefore, the correct answer here is option D, due to the adsorption of ferric ion. If density of gold is 19 grams per centimeter cube, the density of gold is 19 grams per centimeter cube. If 1.9 into 10 is to minus 4 grams of gold is dispersed in 1 liter of water to give a solution having spherical gold particles of radius 10 nanometers, then the number of gold particles per nanometer cube of the solution will be, here are the options. Now, the volume of the gold dispersed in 1 liter water will be mass upon density, which is equal to 1.9 into 10 raised to minus 4 upon 19, which gives 1 into 10 raised to minus 5 centimeter cube. Now, the radius of the gold soluble particle is given as 10 nanometers, which in terms of centimeters is equal to 10 into 10 raised to minus 7 centimeter, which is equal to 10 raised to minus 6 centimeters. Now, the volume of the gold soluble particle V is given as 4 by 3 pi r cube, where R is 10 raised to minus 6 centimeter. So we'll get the volume as 4.19 into 10 raised to minus 18 centimeter cube. Now the number of gold soluble particle in 1 into 10 raised to minus 5 down into 10 raised to minus 5 centimeter cube will be equal to 1 into 10 raised to minus 5 upon 4.19 into 10 raised to minus 18, which gives the answer as 2.38 into 10 raised to 12. Now this is in centimeter cube, however we have to convert this into nanometer cube, so the conversion will be given as 2.38 into 10 raised to 12 upon 10 raised to 6, which is equal to 2.38 into 10 raised to 6, which is approximately equal to 2.4. Therefore, the correct answer is option D. The surface tension of a soap solution is 30 into 10 raised to minus 3 n upon m. The work done in stretching a bubble of this solution of surface area 5 cm into 5 cm to an area of 10 into 10 cm is, here are the options. Now the work done is given by the formula 2 into A2 minus A1 into S. So now here we'll substitute the values of A2, which is 10 into 10, which is area 2, and this is area 1. So minus 5 into 5 into 10 raised to minus 4 meter cube into 30 into 10 raised to minus 3 n per slash m. Therefore, on calculating all this, we'll get the answer as 4.5 into 10 raised to minus 4 joules. Therefore, the correct answer is option A. Silver atomic weight. Silver atomic weight is equal to 108 grams per mole, has density of 10.5 gram per centimeter cube. The number of silver atoms on a surface of area 10 raised to minus 12 meter square can be expressed in scientific rotation as y into 10 raised to x. The value of x is, here are the options. Now volume of 1 mole of silver atoms V is equal to 108 upon 10.5 centimeter cube per mole. Therefore volume of one silver atom will be equal to 108 upon 10.5 into 1 upon 6.022 into 10 raised to 23 centimeter cube. Now the formula for volume is 4 by 3 pi r cube. Therefore 4 by 3 pi r cube will be equal to, on calculating, we get 1.708 into 10 raised to minus 23. Now, therefore, here we have to find the value of r. Therefore, r cube will be equal to 0.407 into 10 raised to minus 29 meter cube. Now, area of each silver atom will be equal to pi r square, which is equal to pi into 0.407 into 10 raised to minus 29 raised to 2 by 3. So, the number of silver atoms will be equal to 10 raised to minus 12 upon 0.407 into 10 raised to minus 29 raised to 2 by 3, which will be equal to 1.6 into 10 raised to 7. Now comparing this with y into 10 raised to x, we get the value of x is equal to 7. Therefore the correct answer is option A. The capacity to bring about coagulation increases with option A, ionic radii, option B, atomic radii, option C, valency of an ion, and option D, size of an ion. Now here it's all relation to coagulation. Now the amount of electrolyte required to coagulate a fixed amount of solution, a fixed amount of solution depends upon the valency, since valency is the most important factor of the flocculating ion. Hence the valency of the ion is an important factor. Therefore the correct answer is option C. Example of an intrinsic colloid is A, glue, B, sulfur, C, iron, and D, AH2ST. Now what are intrinsic colloids? intrinsic colloid. Now, on shaking with the dispersion medium, with the dispersion medium, colloids directly form the colloidal solution. Colloids directly form the colloidal solution. Hence they are called as intrinsic colloids. Here, glue is the best example of an intrinsic colloid. Rest all are not. Therefore, A is the correct answer. Which is not colloidal? A. Chlorophyll, B. Egg, C. Ruby glass, and D. Milk. Now, egg. Let's look at all the example one by one. Example B is egg. Now, egg is a colloid because egg is a colloidal of solid and liquid. Let's look at example C, ruby glass. Now, ruby glass is also a colloid. It is a colloid of solid and solid. Now, let's look at example C, D, which is milk. Milk is also a colloid, which is a colloid of liquid and liquid. However, option A, which is chlorophyll, is not a colloid. Rather, it is a complex magnesium. It is a complex of magnesium. Therefore, out of all the four, chlorophyll is not a colloid. Therefore, the correct answer is option A. In Friedrich adsorption isotherm, adsorption is proportional to the pressure P as A P raised to 0, B P, C P raised to n, and D P raised to 1 by n. Now, adsorption isotherm is given as log of x upon m is equal to log k plus 1 by n log p, which is equal to log k into p raised to 1 by n. Now, taking anti-log on both sides, we can get x upon m is equal to k into p raised to 1 by n. Here, k is just a coefficient or a variable. Therefore, we can say that x upon m is directly proportional to p raised to 1 by n, which is Friedrich's equation. Therefore, adsorption is directly proportional to p raised to 1 by n. Therefore, the correct answer is option D. Which of the following form cationic missiles above certain concentration? A. Urea, B. Cetyl trimethyl ammonium bromide, C. Sodium dodecyl sulfate, and D. Sodium acetate. Now here, cetyl or alkyl trimethyl ammonium bromide gives R NH3 thrice Br, which aggregates to form R NH 3 thrice plus Br minus. Therefore, here alkyl trimethyl ammonium aggregates to form cationic missiles. Therefore, here the correct answer is option B. The contact angle forming between magnesium stearate and water is larger than that between lactose and water because A. Magnesium stearate is more hydrophilic, B. Magnesium stearate is more hydrophobic, C. Lactose has more surface energy, D. Both have equal hydrophilicity. Now, in general, hydrophobic materials tend to produce large contract angles with water, generally more than 90 degrees. Now, hydrophilic material, they tend form contact angles which are less than 90 degrees. So here, the contact angle between magnesium stearate is larger because magnesium stearate is more hydrophobic. Therefore, the correct answer is option B. The Friedrich adsorption isotherm can be used to model A. Multilayer adsorption, B. Monolayer adsorption, C. Both, and D. None of these. Now, Friedrich adsorption isotherm is used to express the adsorption of multiple layers of the adsorbate on the surface of the adsorbent. Now, why this multiple adsorption happens? This type of adsorption occurs through weak van der Waals forces. Forces between the two materials, and it is usually reversible. Therefore, here, due to Friedrich adsorption theorem, multi-layer adsorption occurs. Therefore, the correct answer is option A. What is the main result of adding surfactants into liquid composed of two immiscible phases such as oil and water? A. Reduction in the interfacial tension between the phases. B. Increase in the interfacial tension between the phases. C. Catalyzation of chemical reaction between the phases. And D. Nothing happens. Now, when a surfactant is added to these phases, the phases uh, as the hydrophilic and the hydrophobic parts of the surfactant associate with the polar and the non-polar phases respectively. So when a surfactant is added, the hydrophilic and the hydrophobic part of the surfactant will associate with the polar and non-polar phases respectively. Now this in turn utilizes the potential energy at the interface into more associations and affinity, leading to the reduction in interfacial tension. Therefore, here the correct answer will be option A, reduction in the interfacial tension between the phases.